Hello and welcome to this repair tutorial, and today we're going to look at a Marantz and the model number is PM7200. In terms of general specifications, power output in class AB mode is 95 watts RMS if you connect 2x 8 ohm speakers. If you choose to select class A mode via the push button on the front fascia, that will deliver 25 watts RMS, but again into 2x 8 ohm speakers. A nice feature is that you can have dual sets of speaker systems connected, and again via the front fascia you can select between system 1, system 2, or have them both. If you wish to bypass the tone control circuits, then you will select that via the source direct mode, and frequency response is 20 Hz to 20 kHz, and total harmonic distortion is 0.03%. In terms of inputs, you have line inputs, and they are coming in 150 millivolts. And you also have a moving magnet direct connection. So if you have a turntable, the input sensitivity there is 2.5 millivolts. And overall dimensions, the width of the amplifier is 440 millimeters by a height of 159 and then a depth of 275.4. Now this amplifier, in terms of build quality, excellent. So its substantial weight here coming in at 12.3 kilograms. And then what I've also done as well is in the repair description, I'll put a series of links to other Marantz PM7200 tutorials. So again, if you wish, you can go and look at those to gain more insight. Now this amplifier came in from a customer who had contacted me after seeing one of the repair videos on the channel. And the first thing that I want to sort of highlight before we sort of get into what were the issues that we were seeing is the rear back panel of the amplifier. And I've sort of described this in many tutorials, not only for Marantz but other types of makes. Whenever you do a disassembly of an amplifier and you're doing fault finding, of course you come to the point where you need to do some form of functional test, and it's very, very important for this amplifier that you ensure that the back panel is in place, because it has what we term as a common ground connection. So on the circuit board, what you have are the speaker terminals which come through, and there's actually a grounding pin. What will happen is that when you put the screw in, it will actually ground the back panel, but also the circuit board internally with a common ground connection. Now, the issue with this amplifier is always the same. It's always age related. So again, if you own this amplifier or you're considering working on it, what I would say is in terms of time, just allocate probably about 4 hours. And 4 hours will give you the necessary time to concentrate on the multiple issues. But if you take your time and work systematically through, what you'll be rewarded with is the reliability of the amplifier will be returned, but it will give you many, many years of listening pleasure. And I do like working on these series of amplifiers. They are very modular in construction, and it's very easy just to take out the relevant parts of the amplifier, put the remaining part of the amplifier to one side, and then work on that specific circuit board. So what we're showing you here is the input selection circuit boards. And I say boards because there is also another board which you can see that plugs into the main part of that circuit. And then what you can also see are the input selection relays. So what this amplifier is not doing is doesn't use mechanical switching in terms of maybe a rotary selector on the front. Yes, there is a rotary selector, but it is read in turn by the microcontroller, which will send the command signal out to select the appropriate relay and energize it and bring the signal in. It also doesn't have an analog integrated circuit, as you would probably see on ladder types of amplifiers. And then what you can also see is the signal cable. Once you've removed the back panel, what you're able to do is to gain access to these circuit boards. And for people who are maybe new to the channel, what I do here is I just provide insight. So again, if you follow through all of the information which I show you here and describe, you should be rewarded with a working amplifier. And the most common issue that you find with these Marantz amplifiers is dry solder joints. But what I've done here is I've just highlighted particular areas, and it's always around the RCA input connectors. And the reason being is twofold. First of all, it's a mechanical stress point where you connect different inputs. But also as well, the circuit boards are not soldered by hand. They go through a flow soldering machine. And what you can find is the amount of solder which is transferred is quite sparse. So over time, you can find cracking around those input RCA sockets. So just focus on them and then reflow new solder, and don't be sort of conservative on that. Put a good proportion of solder on, and that just ensures that strong mechanical bond. You also need to look across the circuit board where the smaller board plugs in. You will also find other areas where you find dry solder connections. And if you wish, if you see any excess flux, then you can easily clean that up. And then here what you can see is the input board. Now there's something a little bit sort of curious on this amplifier. What I would say is that this amplifier had been worked on previously, and whoever had actually undertaken the work clearly had some knowledge. But what they've done here is they've actually removed two capacitors from the circuit board. These capacitors are 680 picofarad, and they are on the input phono stage of the amplifier, so the moving magnet. And they appear to have put some dots onto the circuit board. So what I've done here is I haven't reinstalled those capacitors. I've kept it exactly as it came in. And then you can see here where those components have been removed. You'll also see later on when we get to the main amp board and then the alignment that there's also been some additional work carried out. And then here, if we take a look from the top, this is now with the input selection boards have been removed. And then what I've also removed is the main power amplifier. And as I said, it's very modular, so you can just put all of this chassis to one side and focus on the amplifier module. And then here, when we look at the solder side, this is a major focus area. You're always going to find multiple dry solder joints throughout the circuit board. What I would also say and highlight as well is you have to pay attention to detail here. These solder connections are very, very close together, and if you're not careful, you may accidentally create a solder bridge. So take the time. Just be very precise on what you're resoldering. And before you move on to the next connection that you want to solder, just verify that there isn't any form of solder bridge. And some of these circuit tracks are very, very thin as well. And you want to avoid stressing, for example, the legs of some of the transistors, because it's very easy then to break the circuit trace away and then create an open circuit condition. You make sure that each one of those solder joints is precise and there's no issue. The other area of focus as well is on the speaker protection relays, and there are actually two of them. And what I'm showing here are the two relays replaced. Because it's age related, what you can find is that the switching contacts become oxidized and worn, and often the customer may complain that they're hearing some form of distortion, or sometimes they describe it as intermittent connections. Sometimes it will work, sometimes it won't. The intermittent loss of signal on one or both of the channels. Now, for myself, I carry multiple relays in stock. Just ensure that you fit high quality relays. Often nowadays, the relay top covers cannot be removed. They're like a sealed unit, which is good because that helps to prevent oxidization. And then what I'd also highlight here, and you can see this arrow pointing to this vertical board, this is the speaker protection board. So you have a dedicated IC, of course, which is then monitoring for any excess DC, which potentially could be switched through onto the individual speaker terminals at the rear. And what the point of the circuit board is twofold. First of all, if the amplifier is operating correctly, if for whatever reason the amplifier develops a fault and you have high DC on either channel or both, the integrated circuit will detect that, and in turn it will then operate the relay. And when I say operate in normal mode, if it's selected from the front, system 1 or system 2, the relays will be energized. It will de-energize the relays, and then they will then prevent any excess DC being passed through to your connected speakers. The other part is that when you power up the amplifier, because the large power supply capacitors and other capacitors on the boards take time to charge up, the last thing you want to do is to hear that noise through the speakers. So typically you have about a 4 to 5 second delay before the relays then will switch over. Now, the issue with this circuit board is the same as all of the other circuit boards, and that is dry joints. So this is the circuit board removed, and it's very, very easy. You just remove the locking mechanism from the top, a single screw, and then you can then unplug the circuit board. And there's not a lot going on here. As I said, there's your dedicated IC. There's a number of electrolytics and associated resistors. But when you flick the board over, this is where you find the dry joints. And again, it's probably been flow soldered. It's not been manually soldered, so very sparse on how much solder has been used. So just take your time, resolder all the connections, and then also on the multi-pin connector as well, where it plugs in. Once that is done, the next area of focus is on the large power supply. And you can see here the board is still installed, and you can see these large electrolytic smoothing capacitors, and towards the rear you can also see a small transformer, and that is your startup transformer, and that is used then to provide, once it has been rectified, smoothed and then regulated, the startup voltage then to the microcontroller. What's interesting on this amplifier is that there is still a mechanical switch which is used to power on and off the amplifier, and you can just make that out on the left hand side, and then it then connects to the plastic mechanism and then through to the push button on the front. Now, what we started to see with this amplifier, and again it's kind of strange sometimes on environment and what the history of amplifiers are, what I've done here is I've just circled around these connections. Now, this is not flux. What this is some kind of organic growth, so it could be mold. There's something going on there. And of course, because it's like organic, what we don't want to have, because it must be moisture based or would have been moisture based at some time. So what I'm not going to do is just to flow new solder onto there. The best course of action is to desolder or to remove that existing solder because it's contaminated, and then I will use a flux removal just to clean off the connection pad and also the pin that I need to resolder, and then I apply brand new solder. And I saw this on this input connector, but then if we focus on here, which is even more concerning, this is one of the voltage regulators, and that's a major problem. As you can see, it's actually connecting directly between the input to the voltage regulator, the ground connection, and also the output connection. And as I said, this isn't flux. There's something growing on here. Again, same course of action, desolder the connections, clean it all up, make sure the solder pads are nice and bright, and then apply brand new solder. And then here what we're showing is the class A, class AB relay. Now what this is doing is it's just switching the power. So in class AB mode, then the amount of voltage is much higher than when it's in class A mode. And I sort of described this in some of the other repair tutorials. My area of focus is on those switching contacts. Because it's switching current, and also of course the voltage, they just become tarnished and to some degree oxidized. What I'm just looking out for is to make sure the switching contacts have not become pitted, and maybe there's some form of arcing because the contacts have worn away, but they hadn't. It was just light oxidization, and just taking a fiberglass pencil and just stroking it across the contacts, return them back to a nice bright condition. I also just give them a clean with some De-Oxit as well. What I always advise, and please do not do this, is to take something like sandpaper and sit there sanding away at the connections. Don't do that, right? Because it has a special coating on there because they're switching contacts. And also as well, what you don't want to do is disform, or maybe you wear away one side of where you've been sanding and it's not making full contact. Now what I do is I always remove it from the circuit board because it's easy then to remove the plastic top case and then just solder it back in place once you've carried out that work. And then here what we're doing is we're actually looking at two parts. So what you see here is again a power supply section. So this is used for the signal processing side. So this is on the tone control circuits. And then the board which is just mounted vertically, this is the volume control circuit board. What we need to do is we need to remove this front bezel because I need to get access to the solder side of that circuit board because I know that there will be definitely dry solder joints. And I also need to get access to the control potentiometers and switches and clean them with De-Oxit D5. Now this photograph here highlights the issues that we saw on those other circuit boards as well. And straight away this is this organic sort of growth, mold, whatever you want to call it. And these are the tone defeat switches. So what I do is I just desolder, as we said, make sure that all of that contamination is removed, clean it all up, and then resolder again then. Now once that has all been done and the amplifier is just reassembled, we're at the position where we need to do the alignment. What I've done here is I'm just showing you an extract from the service manual, and you can see here that we have 3 adjustments to make. The first one is that I need to adjust the DC offset. Effectively what you're doing is you will be connecting your multimeter leads to the rear speaker terminals. Just make sure that system 1 or system 2 is selected because we want the output stage of the amplifier to be connected so you can make the measurement. And then you can see here that we will be making an adjustment so that your reading on your multimeter will be plus or minus 10 millivolts or better. If it's higher than that, then you need to make the adjustment. But again, there's always tolerance. And then your next measurement and adjustment is you will select that the amplifier is running in class AB mode, and then what I'll be doing is measuring across the emitter resistor, and then I'm reading until I have 18 millivolts, and I'm just doing the adjustment. And then finally I just select class A mode from the front, and then the bias value I need then to set to 90 millivolts. Now what you'll always find is there will be some drifting over time. And here what we show you are two things. I've sort of highlighted them with different coloured circles. The one in yellow is the emitter resistor, and as you saw on the previous extract from the service manual, this is where you're going to be doing the measurement. So I'm just connected to the outer two pins, and then I just make the measurement. And then the other thing that I'm highlighting is this red circle around these two presets. And then also there's a third one, if you can just make it out, just to the right hand side. That is the preset which is used to set the DC offset, and I'm just sort of pointing also as well to the metal screening can, which is over the long tail pair or the input stage of that part of the amplifier. Now I said previously that some work had been done on this amplifier. This is additional work. So what has happened is that normally that there is a single term preset in these positions. Now someone has installed a multi-turn preset, so these are 10-turn preset potentiometers, and the reason why that is done, or the reason why someone has done that, is just to provide more precise adjustment when setting these measurements. Sometimes what is probably more difficult is with these multi-turns is if maybe they were dirty, it's more difficult to sort of get access then to clean them, whereas with the single turn presets normally they're open, and then you can spray some De-Oxit onto there and clean the contact and then also the carbon track. If you had issues here, you probably need to replace these presets, but they're not very expensive. And then here what we show is the measurement for the DC offset. So you can see here that it is actually 2.08 millivolts. So it's very, very low. And then this is for the left channel. And then we also made the measurement then for the right. Now in terms of warm-up, this is quite a big amplifier. So normally I say probably about 20 minutes, but for this amplifier I just leave it running probably for about 40 minutes. Make sure that the environment is nice and stable, you don't have any drafts, and then I'll make the adjustment. So you can probably improve here on this 2 millivolts, but you saw previously as long as it's within plus or minus 10 millivolts then you're okay. But if you want to be like a perfectionist, you could probably make some adjustment and get it really as close to 0 millivolts as you wish. And then on this photograph, what we're showing here is the amplifier is now running in class AB mode. And what I said was we just connected across the emitter resistor, and you can see it's a little bit high. It's just under 21 millivolts. So what I do is just do the adjustment, and what's nice on the board is you'll actually see next to the preset it says AB, and then on the other preset it says A, so you clearly know which one is the one that you need to adjust. And then we realign that then to 18 millivolts. And then here you can see the connection. So there's one of the emitter resistors there, and you can see the different presets. And then here, this is not uncommon. So you can see that we're about 106 millivolts. So in class A mode, this should be around 90 millivolts. And you found this on both channels. Both of them are running high. What you'll also find as well is you'll hear the power transformer, because remember, unlike AB mode, in class A mode, maximum current is being drawn, and you can hear that from the power transformer. It's sort of humming away because it's being overdriven or there's excess current being drawn. As soon as you adjust it back to 90 millivolts, then it just returns back to its normal operating frequency, and you can hear the change as well. But remember that when we are doing these adjustments, I've got the volume control set to minimum. Your user controls are then set to midpoint, and I don't have any speakers connected. And very important just to make sure that the amplifier is stabilized. And I'll sort of make the measurements in multiple times after adjustment. Just wait for the amplifier to restabilize before you say, okay, I believe now that everything then is complete. So on this photograph, you can see that we've adjusted it just slightly above 90 millivolts, and you'll see there's a small fluctuation. And then here, if we take a look from the top, this is the amplifier now fully serviced. As I said, I really do enjoy working on these amplifiers. And then here I'm just showing you, as I always do, a photograph of the parts which have been removed. And here these are the two switching relays, 24 volt DC coil, And then your contacts are double pole, so independent switching contacts for your left and your right channel. More commonly, what you'll find is that the relays maybe you purchase have 6 pins on them, because you also have what we term as the normally closed contacts, which is when the relay is de-energized. You can actually cut those pins off, because we're only interested in the normally open contacts, which are the ones that make when the relay energizes, and then you'll be able to use those relays. And then here we just show from the front. So this is the amplifier in test mode, and I'll probably leave it running for about 4 hours, and this amplifier performed flawlessly. Really, really nice amp. So that sort of brings us to the end of this repair tutorial. So as always, I really appreciate you stopping by. And if you have any questions or you need any support, as many of you have done, just drop me an email at audioamplifierservicing@aol.com, or just leave a comment in the channel and I review them on a regular basis, and I will of course reply any comments or any questions that you may have. So until the next time, I wish you all the very best. Cheers and bye-bye.